Hello. We have already seen about the IPv4, IPv6, the need of classful and classless addressing in the previous class. Now let us come to the topic of address mapping. Why do we need to map the two different kind of addresses? Physical address, one side we have, and on the other side we have the logical or the IP address. Why do we need to map these two kind of addresses? Now, internet, whenever we talk about internet, there is a combination of physical network which are connected by a group of intermediate devices, internetworking devices such as routers or switches or any other devices. So whenever we need to transfer a packet from one source, say a host, to another destination, say another host, it needs to pass through multiple networks and the networking devices before it reaches the host on the other network, or it can be also be in the same network. Now the hosts or the routers at the network level, they are identified by the IP addresses. But whenever we need to consider about the next two layers, the last two layers, that is the physical and the data link layer, we need to consider about their physical address. Now, at the physical level, the physical address comes into consideration. And what is physical address? The physical address is the 48-bit MAC address. Now, a physical address is the logical address that is within concentrated on the local network only. Why it is called physical? Because it is implemented by the network hardware, that is the NIC. So what we see that the physical address and the logical address, these are two different identifiers and both of them needs to be mapped. Why? Because a physical network such as Ethernet can have two protocols at the network layer, and a packet at the network layer can have two different physical networks. So there is a need of mapping these two, logical and the physical address. Now, to be able to do this mapping, it can be done in two different ways. It can be done in static as well as dynamic way. So whenever we come to the static mapping, there is a creation of a table that will associate that will map the logical address and the physical address. On one hand, on one side we will have the physical address, and on the other side we have the logical address. So this table, it is known as the static table. So what we see that there is a, on one side we have already told that on one side we will have the physical address, on the other side we have the logical or the IP address. Whenever a machine needs to find out the IP address, it needs to look at the table and find the corresponding IP address of the physical address, and vice versa it will occur. But this static table has a limitation in different ways, because the logical address of a network can be changed in different ways. What are the different ways in which the logical address of a machine can be changed? Suppose a machine, it changes its NIC. So upon changing its NIC, its physical address is replaced by a new physical address, and in that circumstances it may change. In other circumstances, suppose in LAN like local talk, whenever we switch on the computer again after some restart or restart, there's a new logical address that is being assigned in some LANs like switch talk, local talk. This is an example where the physical address is changed. In another situation, we can consider that a mobile computer it moves from one physical network to another physical network. In that circumstances, also the physical address can be changed. In other hand side, we can see that the logical address of a network can also change in different circumstances. A host or a machine, if it switches from one network to another network, then since there is a network change, the IP address will change. Or if the modem is reset, sometimes the logical or the IP address can be changed. Or if suppose a host gets connected to the network via a VPN, virtual private network, in that case also the IP address changes frequently. So in the cases where there is a change in the physical or the logical or both, in those cases the static mapping will not help. Why? Because we need to update the static mapping table on a regular interval, and this will hamper the overall network performance. So in order to remove these limitations, we have another type of mapping which is known as dynamic mapping. In this dynamic mapping, what happens? The two address, that is the logical or the physical address, can be altered by a protocol when we know either of them, either the physical or the logical, then the other one can be updated. Now, in the first, whenever we will, in the first case, we will see about ARP, which will map the logical address with the physical address. Now, we are saying that ARP, address resolution protocol, is the full form of ARP. It is mapping the logical address to the physical address. What is logical address? IP address, and the physical address, it is the MAC address. So what we see that a host or a router, whenever it needs to send a datagram to another host or router, it has its IP address. The IP address that is obtained from the DNS, or for the host it is found in the DNS server, or for the router the IP address of the router can be found in the routing table. But the IP datagram must be encapsulated into the frame, and it is needed to be sent through the physical medium via the physical and the data link layer. So whenever the IP datagram is encapsulated into the frame and sent over the physical network, it needs the physical address. Therefore, we need to know both the logical and the physical address at the same time of the destination machine or the receiver's machine. Now, how does ARP perform? We'll see to it. Now, first of all, the ARP knows the IP address of the target machine or the destination machine. So, what does it do? It first sends an ARP request message. ARP request message, it is sent to all the computers which are there on the network. This ARP request, it is containing the sender's IP address, the target IP address, and the physical address of the sender. The target physical address or the destination physical address, it is unknown, so it is filled with all zeros. Now this ARP request message, it is passed on to the next layer from the network layer, that is, it is now passed on to the data link layer, where it is encapsulated into the frame, and by using the physical address of the sender as the source address and physical broadcast address as the destination address, and then it is broadcasted. It is broadcasted to the entire network. As we do not know that who is the host here, which one is the destination machine, we only know the IP address of the destination machine, so it is broadcasted. The frame contains the broadcast destination address. All the stations except for the target one, it will remove the message and it will pass on to the ARP, and they will drop because they do not require the IP address of the destination machine and their machine. It does not match, so it will drop the packet. Only the target machine recognize its own IP address and it will accept the packet. Now, what will the target machine do? It will send the its physical address, and this physical address, it is being directly sent to the sender machine. Therefore, the reply need not to be broadcasted. It is just unicasted message, and the sender, it will receive the reply message from the receiver. The reply message will contain the physical address of the receiver, and it knows after it knows the physical address of the receiver. It now has all the information. So the IP datagram which carries the data for the target machine, it is then encapsulated into the frame, and it is then unicasted into the destination. Now we will see the diagrammatic representation of this entire procedure of the ARP. As we see that here this is the source. It sends the ARP request. It is being received by all the machines as it is a broadcast message. All the other machines, it will drop the packet, and only the target machine, that is the system B, it will accept the request, and after accepting the request, it will embed its own physical address and it will send it via a reply. Now you see here the ARP reply, it need not to be broadcasted because it is one-to-one delivery. So from the target machine, it is directly, the reply is sent directly to the source machine with the physical address of the target machine. Now this is the overall operation of the ARP. So today we have discussed about the mapping, address mapping. Why do we need the address mapping? What are the different ways to do address mapping? And we have seen the basic operation of the ARP. Thank you.